quick review here, everybody, from yesterday. We talked about what concentration is, and that it's a way of telling how much of something is dissolved in something else, those somethings being solute and solvent. So solute would be like salt, and the solvent would be like water. So the concentration tells us ultimately how many moles of something we have in 1 liter of that thing. So when we looked at those different hydrochloric acid solutions and how they dissolved that metal, the one that had a very high molarity had a large number of moles in it for every liter. And those particles, those HCl particles, were just able to collide with the metal and dissolve it and react a lot faster than the one that had less moles per liter. So that was that. We talked a bit about making up solutions. And then there were quite a few practice questions yesterday about concentration. Did anybody have any of these questions that they wanted me to go over, or do you feel okay with them? Were there any that were tricky? Number 70? Sure. Okay, so let's do number 70. Did everybody else get to number 70? Okay. So we are going page 98. Question number 70. And I'll grab a different piece of paper to write this on. Oops. Okay, so question 70. We are asked how many grams of sodium phosphate are in 3.45 liters of 0.175 molar. And then this is where we might encounter a little bit of a trickier part. Na3PO4, and it's a hydrate, 12H2O. Okay, so let's go through that. And do I have my calculator handy? Yes. Okay, good. All right, so first thing we're going to do is we are given our concentration. Our C is 0.175. We're given our volume, our V, which is 3.45 liters. We don't need to convert it. It's already in liters. We are good to go. And what we're looking for is grams. So we're going to have to find moles, and then we're going to have to use the molar mass and get to grams. Okay, so let's go through that process. So what's the formula that we're going to use if we're looking for number of moles? What's N equal to? So we can rearrange this formula, but moles is equal to concentration times volume. So I'm going to go N equals CV, and that means 3.45 liters times 0.175 molar. Whoops. Okay. Calculator is struggling. There we go. 3.45 times 0.175. Okay, 0.60375 is what I got here. So that's how many moles are in our in this solution. Now, if I want to go from this into grams, I need to use the molar mass. This is my molar, this is my actual molecule, so I need to find the molar mass of that whole thing, right? So what I'm going to do is go, what's the molar mass of this? Did anybody calculate that? Can anybody calculate that? Any numbers? $373? $380? 380? And 375? Did anybody else get different numbers? 342? Okay, let's go through this. Okay, so we've got sodium, 3 sodiums. So I'm going to go 3 times, what's sodium? 23. Plus phosphorus, which is 31. Yes. Na. Oh, okay. Yeah. It should be 380, I think. Yeah. So that's what I got, was 380. Phosphorus, 1, and then 4 oxygen. So yeah, let's go through the whole thing. 4 oxygen, so 16. And then we've got a whole lot of hydrogen and oxygen. So what we've got is 24 hydrogens, which are 1, and we've got 12 oxygens, which are 16. Okay, so if I throw that in my calculator, 3 times 23 plus 31 plus 4 times 16 plus 24 plus 12 times 16. It's a huge molecule. Oh, 337, right? Oh, I got 380 the first time, and then I just redid it and got 337. Okay, 3 sodiums, 1 phosphorus, 4 oxygens, 24 hydrogens, 12 oxygens. Okay, that's right. So let's do it again. 3 times 23, 380. Okay, let's just go with that because that's what I got the first time. Okay, so 380 grams per mole for that whole thing. All right, so now what I'm going to do is go, okay, I have got 0.60375 moles of this molecule. Of this thing, which is 380 grams per mole. So I'm just going to multiply grams per mole. And if I do that, I get 0.60375 times 380 equals 229.4. Okay, and that is now in grams of Na3PO4 12H2O. Oh, but we're looking for grams of the Na3PO4 part. Okay, did everybody get here at least? Does this part make sense to you all? Yeah? Okay. And then we should have to do one more step, right? To just get the Na3PO4. I misread the question. Okay, so okay, to deal with a hydrate, that's the grams of the whole thing. But we do have, okay, so we have 0.60375 moles. Sorry, I'm going to rewrite this just right here. 0.60375 moles of this entire thing, right? Does that make sense? We've got that. PO4, 12H2O. Okay, but what we can do, if we're only looking for this one, is we can just use the molar mass of that. We don't need to use the molar mass of the whole thing because then that's going to give us the mass of the entire thing, not just the mass of the sodium phosphate. So what I'm going to do is find the molar mass of sodium phosphate, which is going to be a lot easier than that other one. So 3 times sodium is 23, plus phosphorus, which is 31. I don't know why I always want to call it phosphate. Plus 4 oxygens. So the molar mass of this is 164 grams per mole, right? Okay, so if we're just looking for the mass of the sodium phosphate, not the whole molecule with a hydrate, we're only using that molar mass. So now we can just go 0.60375 moles times 164 grams in every mole. So there's 164 grams of sodium phosphate in every mole of sodium phosphate 12 is, I don't know, hydrate. So what we're going to do is 0.60375 times 164. Okay, and we're going to get 99.015 grams. And how many sig figs should I have? 3. So 99.0 grams. Okay. So, sorry, I just did an extra step here. You do not need to use the mass of the hydrate. You just are using the mass of the sodium phosphate. Yeah. No, because it's 99.015. So it's the one there that would affect it. Yeah, I hit it on the line. Okay. Does that process make sense to you guys? Okay, cool. Yeah, so it's just, if it's asking for one thing within a hydrate, you don't use the whole mass of the hydrate. If it was asking for how many grams of Na3PO4 12H2O, then you would use the whole mass. Sound good? So yeah, you can actually isolate one atom or molecule within something. So you could also find how much the mass of sodium is within this by doing this same process, but just with the molar mass of sodium. Yeah, that's a little bit of a kind of interpret it a little bit further question. Cool. Any other ones that you guys want me to go over from this? Or are we good to move on to dilution? Okay. So dilution is the next thing in concentrations that we're going to talk about. This is something, do you all know Clea, the education assistant? No, yeah. She's awesome. She is our lab technician here, and she actually does a lot of diluting chemicals. So sometimes we want really strong chemicals, like for a grade 11 or 12 science class, I'm probably going to work with like 3 or 4 molar hydrochloric acid. But with a grade 10 class, there's no way I'm letting them near that. I'm like, you get like 0.5 molar because you're going to burn your skin off. So she does a lot of diluting to make it go from a certain molarity to a really specific other one. To do that, you can't just dump in an unknown amount. You have to be really specific and actually do some math. And I think you guys will be pleased to find out that this is not the most complicated math to do. So diluting is just when more solvent is added to a solution. And then it's going to become more dilute, which means decreased in concentration. Okay, so it's decreased in concentration, but the number of moles of the solute doesn't actually change. So how many moles you have, how many actual particles of that thing you have got doesn't change. They just now have more space to occupy, so they're more diluted. Moles. Okay. So remember from yesterday, concentration times volume gives you the number of moles. So N equals C times V. So the moles in a concentrated solution and the moles in a diluted solution can be calculated using this information. So number of moles, it's the same formula, but we're just adding N concentrated, C concentrated, V concentrated, and then the after is N diluted, C diluted, and V diluted. So it's the same formula, but we're just going to be changing the volume and the concentration. So again, moles in concentrated solution are equal to the number of moles in the diluted solution. Okay, and when you have got two equations that look like this, as you've probably done in math before, you can actually just make them equal to each other, and then you've got a nice algebraic expression, and you can solve for different concentrations and volumes. Just going to zoom in on this a little bit. So we've got C concentrated, V concentrated is equal to C diluted times V diluted. So the other way you might see this written sometimes, the way that I often write this is CI for initial, VI for initial equals CF for final, and then VF for final. So you've got your initial concentration times your initial volume is equal to your final concentration times your final volume. That's usually the way that I write it out, but this is kind of the more technically correct. Again, chemists are lazy and we just like to use less words and letters when possible. Okay, does that make sense how we got from here to here? All right, so this is the same as saying the concentration of our diluted solution is equal to the concentration of the concentrated one times the ratio of the volume before and after. So you can use this formula to figure out what the concentration of your new formula is. It's just this one rearranged. All right, let's do an example. So if I've got 200 milliliters of a 0.5 molar sodium chloride solution, and I add it to 300 milliliters of water, what is the resulting concentration of sodium chloride in the mixture? All right, so here's the thing that we don't have to do we've been doing this in other calculations. If we're doing a concentration to concentration comparison, as long as our volumes are in a consistent unit, we don't actually have to change them. So as long as you're going from milliliters to milliliters or liters to liters, you're good. It just has to be the same. You don't have to change this to liters if you don't want to. So what we're going to do is, okay, concentration of sodium chloride in the diluted solution. So we're just using that equation from the last page is equal to the concentration of sodium chloride from the concentrated solution multiplied by the ratio of volume. So volume concentrated over volume diluted. Okay, so then that concentration is 0.500 molar. Okay, so we're just going to replace what we know in this formula. So we want concentration of sodium chloride diluted. So we're going to go 0.500 molar was our initial concentration times our volume concentrated was 200 milliliters divided by our volume of diluted, which is 300 milliliters. And what we should end up with is 0.200 molar. So we're just applying that formula. Okay, any questions about this? All right, we're going to step it up a notch and mix two solutions. So in this one, what we're doing is we've got our sodium chloride and it's a certain concentration, and then we're just adding pure water. But what we're going to do now is we're going to have two solutions of varying concentration, and we're going to pour one of them into the other and then see what the resulting concentration is. So it's like this, but on steroids. We're going to level up a little. Okay, so when you're mixing two solutions, you have to do a dilution calculation of each of the solutions separately. And then you add the results together to get the overall concentration of the mixture. So you do two dilution calculations, you add them, and then you're going to have the overall. In order to get a more accurate answer, keep more significant digits. I guess the way that should be worded is like keep more than the significant digits. Just keep the more digits you keep as you're going through the question, the better. Okay, so let's do an example together. So we have 300 milliliters of a sodium chloride solution, that's 0.250 molar. And then we have 500 milliliters of another one, which is only 0.100 molar. And then we want to know if we mix those two together entirely, so we dump one all the way into the other one, what is the resulting concentration? So solution one, we're going to do the calculation for that. So we're going to go NaCl concentration diluted. And we are just pretending essentially that we're mixing it with water. We're doing the exact same thing that we did in the other question. We're just multiplying the concentration of the initial one by the ratio of volumes. Okay. So for solution one, I've got 0.250 molar. What is my concentration of that one when it's more concentrated, or the initial one? Cool, 300. And then what's the final diluted? 800. Yes, good. Okay, so when we do that, we should 300 plus 500. Yeah, so because what we're doing is we're mixing both of those. We're dumping one into the other. So we're starting off with 300 milliliters of this one, but then once we mix the two, we have 800 in total. Yeah. In the first question, we had 200 and, oh, sorry, no, we should have, that's my bad. I actually wrote this wrong. I did the math with it being 500, but I wrote it as 300. So yeah, go back, change that to a 5. My bad. Thank you for pointing that out. That math should still be correct though. Just had a moment. 0.5 times 200 divided by 500. Okay. Yeah, 0.200. Do you guys get why we're adding them though? All right, so in this one, the final volume is 800. And what we're going to end up with is 0.0625 molar for our solution 1. Okay, but that's not the whole story. We had a whole different concentration in the other one. So we're going to do the same thing for the second one. Okay, so I want you all to take a moment and do this for the second solution. So this one here. Okay, so do that. I'll give you a few minutes. Put your hand up. On this one? Yeah, that's right. I wrote down the answer for the second part. Hold on one second. Yes, but I mean, you're missing. No problem. But yeah. Just make sure you check in with Mr. Huff. Yeah. All right. So did anybody, or sorry, I haven't given you enough time yet. Take another minute. Yes, sorry. What was your question? Yeah, great question. So you guys, for the second solution, we've got 500 as our initial volume, and then our diluted is going to be the two added together, so 500 and 300. Yeah. Because our second, so this is solution 1, that's the 300 ml with the 0.250 molar. And then solution 2 is 500 mils of 0.100 molar. So we're doing the two solutions separately. Okay. Okay. So let's go through here. So for solution 2, what did you guys put down for the concentrated NaCl? Yeah, awesome. Okay, and then what did you guys put here for this ratio? Awesome, 500 over 800. And then what did we get for the concentration? Sweet, which is what I accidentally wrote down for the last one. Sorry about that. Okay, so awesome. We have got the concentrations of our diluted two mixtures. what we do now is the total concentration. We just add those together. So we're going to go 0.9375 plus 0.0625, and what we end up with is 0.156 molar. Okay. Does everybody follow how we got here? Yeah, you just add them together. Yeah. What? How am I so bad at adding today? Like, what is going on here? Oh, because this one's 0.09. Gotcha. Yeah. So it is 0.156. My math skills are off today a little bit. Okay, we are going to do 2 more examples, and then I'm going to let you all work on some questions. Does everybody have this one written down? Okay. All right. So what we're going to look at now is making dilute solutions from concentrated solutions. So the calculation, it's based off the fact that the moles of chemicals in the diluted solution is equal to the moles of chemicals poured from the concentrated solution. So this is all based off of having the same number of moles in the diluted and the concentrated, but just different volumes. So the moles, the N value is the same. It's just the volume that's varying and the concentration. All right, so we're gonna figure out what volume it takes to make 0.125 molar HCl, and that should not be capitalized. That should be HCl lowercase l, from 6 molar HCl. And we want to know the volume. So what I'm going to do is write this out as, you can choose what to do here. I just really like initial and final. So I'm going to go volume initial, concentration initial is volume final, concentration final. And what I'm doing now is my initial volume is my unknown. I want to know what volume. So I don't know. We'll leave that like it is. My initial concentration, 6.00 molar, equals my final volume. I want to make 2 liters. And I've got 0.125 molar as my final concentration. So now it's just like algebra solving for x, but our x is VI. And yes, I can do. Okay, so if we work through that, our initial volume should end up being 0.0417 liters, hopefully. Okay. Does that make sense, that process? Good. Awesome. Okay, next question here is a student mixes 100 milliliters of water with 25 milliliters of sodium chloride solution, which has got an unknown concentration. But then the student finds the molarity of the sodium chloride in the diluted solution to be this. So we have got our initial volume. Our final volume is going to be these 2 added together. We don't know the initial concentration, but we do know the final concentration. So I'm just going to do the exact same thing as above. VI, CI, initial, equals VF, CF, final. VI, 25 milliliters. I'll just bracket this instead of using multiplication signs. Concentration initial? We don't know it. Okay, what's my final volume, you guys? 125. And my final concentration, 0.0876 molar. Okay, solve for X. Did we get 0.438? Good. Okay, if you are somebody who likes to rearrange equations instead of just plugging numbers in and solving for values, you could rearrange this to be concentration initial equals concentration final, volume final over volume initial. So you can rearrange if you want to. I find these ones pretty easy to just kind of like plug and go. But depending on how your math brain works, you do you. Okay, any questions about that process? This section's a lot easier than the other stuff we did in this unit, hey? Or maybe not? No? Okay. All right, I'm gonna let you all try. What time is it? Okay, so we end at 2:03 today. So what I want to do is spend let's say 10 minutes and just go through as many of these questions as you can. Then we'll take a break. We'll come back. I can go over a couple examples with you if you want, and then we're gonna move on to some review time, okay? So 10 minutes, work hard on these ones, page 102. Oh, I didn't find us a chemistry